All right, students, on this series we'll show you how to find the sum of an arithmetic series. And again, an arithmetic series is any series that's going by either adding or subtracting in between terms. So 5, 10, 15, 20, 25, so on. That would be a arithmetic pattern because it's adding 5 each time. And so you can start with anything and count by anything as long as it's constant what you're changing by. So what we're going to do is we're going to take one of the most basic sequences that you've ever learned, which is 1, 2, 3, 4, 5, 6, 7. And what we're going to do is take it and call it a series, because what we do when we do a series is we try and add up all those numbers. So 1 plus 2 plus 3 plus 4, that's pretty easy. Let's make it more challenging. Let's say we want to add all the way up to 100. All right. So couple things here. Even with calculators, you could type all this in, but it's going to be tedious. Okay, so we want to find a faster way to do that. And two things we're going to do. One, we're going to learn a formula for it, and two, we'll learn how to use a calculator to sum it up for us. Now, this is an interesting question historically, because the story goes that this was given to about a 4th grade class, and one of the students, Carl Gauss, was in the class as a 4th grader, and this teacher gave them this to add up. Now, this is a couple hundred years ago, so they didn't have calculators. So what he did, and he was a lot faster than anyone else because he was, they figured out he was a brilliant kid at a young age. He added up the first and last one and said, that's 101. Okay. But then he added up the next two and said, that's also 101. And then he added the next two and also said, that's 101. And if you add 4 and 97, that's also 101. He said every time you add these pairs of the first one and the last one, and then the next two, and then the next two, and the next two, you're going to end up with pairs of 101. So what he figured out was the sum was 1 plus 100, so the first plus the last. And then what he said, okay, if we're making pairs, if we had 100 numbers and you pair them up, you'll have 50 pairs. So 50 pairs of 101, which would be 50 times 101, which ends up giving us 5,050. And there's our answer. Okay, so he looked at it totally differently, and he was able to find the sum of that by adding the first and last term. Now here's the cool thing. This works for any series like this, okay? As long as it's going by a constant amount, and that makes it an arithmetic series, we can find the sum. So what we want to do is, I tell you the story of Gauss, so hopefully you can memorize it a little easier. The sum, what he did is he took the first term plus the last term, generalized, that would be A1 plus AN. Where did he get the 50? Well, because there are 50 pairs. Well, why 50? Well, he had 100 numbers and he paired them in groups of 2, so that would give you 50 pairs. So we're not always going to have 100 numbers. So however many numbers we have, we're going to pair them, and we'll have n divided by 2 pairs. Because if you had 100 things and you pair them, that would give you 50. If you only have 30 items in your list, well, 30 divided by 2, that would give you 15 pairs. So that's where the n over 2 comes from. So in general, this is the starting value. This is the ending value. And this is the number of terms. And to keep this consistent, let's say starting term, ending term, and the number of terms. That's why everything's in terms. Okay. So for the quiz, I'll actually give this to you. Math analysis, you might need to memorize it. Hopefully thinking about where it came from in his story will help you recreate this. Okay, so the next thing we're going to do in this video then is, how do you find something that's not 1 to 100? So 1 to 100 you could do, 1 to a million you could do exactly the same method. You wouldn't have 50 pairs though, but follow the same method. What I want to sort of focus on now is another arithmetic sequence. Okay, so for example, you can start with anything. Let's say we're going to start with 8. And we're going to grow it by 3. So 8 and then 11. In fact, let's erase that because we're going to add it up. 8 plus 11 plus 14 plus 17 plus ... Okay, so this is an arithmetic sequence, or a series actually. When we add them all up, we call it a series. Just so you know that. So the series continues. The problem is we don't know how far it continues. So what if they say find the sum of first 30 terms, let's say. Now this could be 30 terms, it could be 50 terms, whatever it is. If you know how to use the formula, it's all the same. So find the sum of first 30 terms. Okay. So here we go. If we're going to find the sum, two things we're going to need to know. We're going to use this formula here. Let's put this back. We need to know the first term, we need to know the last term, and we need to know the number of terms. If we have those three things, we're good to go. Problem is, we have the first term, that's 8. We have the number of terms, that's 30, which is n. The problem is we don't know what the 30th term is. We need to know that one in order for this to work. Okay, no problem. There's two steps we're going to do here. Step 1, we're going to need to write a formula. Okay, so this is what we did in that last video. We need a formula because I don't want to continue all the way up to 30. Okay, 30 is not too bad, but if this was 300, that'd be a waste of our time to go all the way to 300. So here's what we're going to do. We're going to say, all right, our formula for this, for any nth term, for some term way down, it doesn't have to be the 30th, for any term, how do we generate them? Well, we generate this list by starting with 8, and then you went plus 3, plus 3, plus 3. Okay, plus a plus there. And so we said, okay, it started with 8, and then went plus 3, and how many times did it do it? It did it n minus 1 times. And if that's not clear why that is, we can go back to the old video. But what it is by the time you get to step 30, you really only added 3 29 times. The reason for that is because you don't count the first step. The first step adds 3 to get you to number 2. So to get to number 30, you just need to take 29 steps. Not 30 steps, because you're already on step 1. So that's why the n minus 1. So if we want the 30th term, we can say it's 8 plus 3 times 30 minus 1. Or as 8 plus 3 times 29. Okay. And I believe this will be 95. Let's fill that in. So now we know the 30th term is 95. Okay, step 2, we're ready to find the sum. Step 2, the sum, we're going to use that same formula, n over 2, and then a1 plus an. So for us, there's 30 terms, so 30 over 2. Let's move this up. Right here. There we go. 30 over 2. The first term was 8. The last term was 95. So without knowing that the last term was 95, there's really no way we can use this formula. So we had to do step 1 first to find the last term was 95. After that, this should be a piece of cake. That's 15. And then we're going to go times 103. Okay. Which I believe will be, no, that can't be right. I was going to put something I thought to myself, that can't be right. So 15 times 103, we'll just use the calculator. 1545. I was going to say 1945, so that can't be right. 1545 is what we got. All right. So hopefully it helps. Between these two videos, you now have arithmetic sequences and now arithmetic series. So adding up the terms. And again, you could go out to 300. You could just as easily go out to 3 million. You can find any number of terms, any sum, anything you want, as long as you have the first term, the last term, and the number of terms. All right, this video is a little bit longer than usual, so thanks for sticking around to the end. Much appreciated. And have a great day and bring lots of questions tomorrow. So tomorrow what we'll do is, if we have this all done, I'll show you how to shortcut this whole process by using the calculator. The calculator does have a method for doing this because it can figure stuff out and it's great at calculating. So there's a method if we know where to find it in the calculator, how to find the sum of a series. All right, thanks for watching, and I'll see you tomorrow in class.